Well, what do we have here? We can just make out it says Sharp Pocket Computer here. And if we open it up, we see a Pocket Computer wallet, which looks pretty much unused. We've got a Sharp PC 1251 and a CE 125 printer and microcassette interface. On this side, we have a power supply, some type of audio cable, and a microcassette. I'm not sure how much this was used. It didn't get a lot of use. It's in really good shape. But of course, after 40-ish years, the belts and the microcassette have turned to goo. And in the back here, it is hiding the manuals. The 1250 and 1251 manual. Or this is the CE 125 manual for the 1250 and 1251, and this is the 1250 and 1251 manual in Japanese, of course, because this unit was imported recently from Japan. It came with a lot of other stuff. Figured we'd go ahead and get the whole lot fixed up. That's where the printer we did last time came from. And I already took this apart to check on the battery pack and the belts. Get the battery pack out of there right away, so you can see the top's kind of loose. I've ordered belts in here. I wasn't quite sure on the sides, so I ordered one on each end of what I thought it might be, based on a Japanese website, which I'll link to down below. The 1251 here works just fine. All I needed to do was put some new batteries in this guy. It's in very good shape. Just a tiny little bit of scratching on the bottom. And I've also made up a new battery pack for it, which we'll be installing. So probably the biggest chore on this thing will be cleaning all the belt goo from the old deteriorated belts out of the mechanism here. So I'll get this set up so we can work on it, and I'll show you how it came apart. Thanks to PCBWay for sponsoring this video. They do circuit boards of all sizes, small circuit boards, medium circuit boards. They can even assemble them for you. They also offer a wide range of services that allow you to go from idea to a finished product, including CNC machining, 3D printing, injection molding, PCB assembly. Go on over to PCBWay.com/OEM to find out more. Okay, I've got you overhead there. It makes it a lot easier to work on things. This is like version 4 of my overhead mount. It comes out even further, so you get less of a weirdly distorted view. There were 5 longish, about 10-11 millimeter screws, plastic screws, and a couple maybe 3 millimeter long machine screws. And this comes off like this. Notice there are some wires here that go to the connector for the computer, so be careful when you open that up. Right here was where the battery pack hooked up. Now this wiring is okay, so I just cut it off here. And that'll be fine. I unplugged this connector here, which goes there. There's also a ground lug which goes down right there. And there is a wire soldered right here which goes up to a cap that's bodged in. Otherwise we could completely separate these two halves. This was the one of the 3 belts in the microcassette which was not turned to goo, so I cut it in half and measured the length. I compared it against the website I mentioned below. It seems in Japan they measure the diameter of the belt, so that's what the website listed. And in the US, belt manufacturers like listing the internal circumference, which on a belt this small, just if you cut it in half and measure the length, that's good enough. There's not enough difference for a belt that's 0.5 millimeter in cross section. So keep that in mind when you're looking up belt sizes from a website. They might be listing either the circumference or diameter, so you've got to use a little common sense. In my case, I looked at the sizes given and I thought, well, that seems too small, and looked at the links they provided and like, okay, they're measuring the diameter. There was just a slight little bit of corrosion in here from the old battery pack, which I cleaned up. It was really not too bad at all. And if we rotate this guy sideways like this, okay, I've got a little Phillips screwdriver, and there are 3 or 4 threaded plastic screws holding this microcassette in. And there's one here by the counter. And one in this corner which has a red wire going over here to this area. So make sure we get that wire hooked back up. This nice beefy motor here. Yeah, okay. And these wires are kind of delicate, so be gentle, and I'm just gonna try to lay a rag in here like that. Keep from scratching things up. This one belt I took off was from here to here, and that looks like it goes to the counter. There is one belt which is still sort of intact here, and there is another one which has turned to goo, and I think it might have gone to over here, but it's so far deteriorated it is hard to tell. Yeah, it was on this top pulley and it went to here, I think, and the bottom of this brass flywheel went to here, and this is the motor right here, and it must have gone, okay, no, counter is just here to here, that's it. From motor to top of flywheel, bottom of flywheel to here. Okay. Just kind of look at it, study it, and it's usually kind of obvious where all those belts go. So it looks like we've got 2 screws here and a slotted hole. So if we take this plate off and slide it back, it should reveal our belts. That screwdriver is not going to do the business. Let's have a very shallow head, so I'm actually going to try a small flat blade. I need to get some better support under here. There, okay. Try the flat blade again. Yeah, because these screws have some thread lock on them right here. There we go, got that one loose. I'll try that same thing. I'll just scratch the thread lock around the screw head. I guess it's not thread lock, it's just a locking paint that's applied to the head. There we go. Okay. 2 itty-bitty Phillips screws. Okay. This also has a switch here. It's probably some type of mode switch, like so you know when the buttons are pressed to turn the motor on. You can see we've got a bit of belt stuck here. There is belt stuck all in this top groove here. Some type of metal slug in this piece of plastic right there. Not sure what that's about, but luckily I don't see a lot of belt stuck around here other places. So I'm going to get a small rag, and you'll get this black goo all over your hands. So I'll clean as much up as I can, go wash my hands with like a mechanic's hand cleaner, and clean more of this stuff up. Take a flat blade, easy for me to say, flat blade screwdriver. Scrape that goo off of there onto your rag. I find a rag made out of an old t-shirt works better in this application than a paper towel. And I'm going to rotate the pulley around while I scrape out the worst of this out of the groove, like that. And then I'll use a finer screwdriver to get a little further into the groove, like this. I'm going to go ahead and pull that belt off of there now. Okay, well, at least 2 of the 3 belts did not turn to goo. So when you're degooifying these things, you want to be careful what you touch. I'm only touching a small number of tools. The rags I don't mind throwing away when I'm done. Got a few Q-tips and some alcohol. Mop up as much goo as I can. And go back at it with the scraper and until you get everything out of the groove. If you leave anything in the groove, it's just going to stick to the new belt, and it'll probably cause the belt to wrap around and you'll break something. So sometimes this can take 30 minutes to clean up one pulley, depending on how bad it is. But that's all there is to it. So when I get this cleaned up, we'll install the new belts and see which ones fit. After about 6 or 8 Q-tips, I got a lot of the gunk off, but I couldn't get in the root of the pulley. So I've got some thread here that I've doubled up. It's a kind of a obnoxious bright yellow color, and it would help if it was a little thicker, but I doubled it up, and I'm going to wrap it around this pulley like so. Hold it in one hand, rotate the pulley in the other, and then slide the thread back a little bit, do the same thing. A little this way now. So this is just getting in the groove of the pulley. Getting the last little bit of stuff off there. Yeah, and if you can see the thread coming out clean, you know you've got it. I'm just not really getting anything off of this now. Yeah, so this one's pretty clean. You can see how black some of those threads are there, and all this black is off of this thing. And I've washed my hands twice already, and I need to do that again. And if I look, and I'll use my magnifier here, be kind of right in your way, but yeah, that looks nice and clean now. There's just a little bit of stuff right there. Yep, nice and clean, and the motor pulley is also clean. I did the thread trick on it too. So now we're ready to put the new belts back on. And I need to figure out which belts go where. Okay, now that we've got our pulleys de-gooified, I made a little map here showing how the belt should be routed. I wrote down the part numbers of the belts I bought, and figured out that since this pulley, which I called B2, goes to the bottom of the flywheel, it needs to go on first. And that guy is one of these two belts, 4.6 or 4.4. I'll put the part numbers in the description below. And remember that Japanese webpage link is down there. And depending on what part of the world you're in, the links to the part numbers that he gave may work better for you. Go, gosh. Come on, snap on there. There we go. Okay. That needs to go down one groove. Like that. The nice thing about these square belts is they will align themselves, and that would probably work. It's not too loose and it's not too tight. We'll try the 4.4 now. The reason I bought both of these belts is I wasn't quite sure. And I work on enough of these things that if I wind up with an extra belt, I'm going to use it sometime anyhow. This is the next size down. Okay. That feels good too. And really, it's hard to tell the tension difference here. So I will say either one of these belts will work. But the slightly shorter one is not too tight, so that is going to be the one I'm going to recommend. The SCY 4.4. Okay, the number 2 belt is one of these two, SCY 5.0 or 5.2. It's about a 35 thousandths cross section, which is 0.8 millimeters. I'll try the longest one again. Then the shorter one, we'll figure out which one works. You can buy great big bundles of belts of various lengths and questionable quality on eBay and Amazon, and sometimes those will work. Sometimes you don't know how long they'll last. Okay. That's not too tight. That would work. Okay. That's the 5.2. Let's try the 5.0. And the last number there, 5.2, 5.0, that is the circumference in inches, which, as you know, is the superior form of measurement. Yes, you know, I'm just kidding. Put away your pitchforks. And that would also work. Yeah, it's not too overly tight. Maybe a bit snug. I'll try the 5.2 on there again, because you really don't want a lot of tension on these things. Yeah, the 5.2 might be just, it would work. It might be just a little floppy. I'm going to go ahead and say the 5.0. Work that around. Yeah, okay. And make sure we put the belts we're not using back in the right packages. I think either one of those would actually work though. And now we've got the big guy, which is either a SCY 6.3 or 6.5. Rotating this around enough to get the belt to straighten itself up. And yeah, that's definitely floppy. So once again, I'm going to go with the smaller one, although I think on the other two, either would have worked. And on this one, I think the 6.5 would just be too floppy. So we'll do the 6.3 now. Rotate that around. And if you watch the belt, you can see as you rotate it around, it will usually take the twist out of itself. This one seems a little determined to be very twisty though. Oh, that's better. Okay. Yeah, that's a good tension. There's plenty of play there, but it's not too loose. Okay, I'm going to say the 6.5 is not, and I'll mark the others as alternatives. So, not use 6.5, but you could use these other two. Again, I'll put the part numbers below. Okay, remember we cleaned the belt goo off of that guy there too. Oh, I missed some. Look at that. And I did check the mechanism to make sure there was no goo that worked itself in other places. Now I'll put those screws back on and we'll fold our mechanism back over and see if we can at least make sure that it's going to run. I actually had to fiddle with things a bit to drop the mechanism back in there and get all the wiring to lay just right. There's a red and blue wire here, which instead of going around the front of the switch like everything else, likes to go around the back of the switch. Actually slid the printer mechanism out of the way to make it a little easier. Now we should be able to get this thing fastened in there. There we go. Remember, on screws into plastic, you want to go counterclockwise. You usually feel it drop into the thread and then start it clockwise. That way you're not cutting new threads in the plastic every time. Okay, I want to get the printer slipped back into place. I just put this rag here to protect the circuit board and printer both. And It just kind of drops down in there on a few pegs. That. Yep, that seems right. Really, the only problems I've had with these printer mechanisms is they can kind of get stuck after years of not operating. Let's see if we can rotate it a bit by hand here. We're just crawling the carriage along here. When it gets to the end, you can see how this shaft looks kind of crisscrossed. When it gets to the end, it actually slips into the slots going the other way, so the motor only feeds one direction. And then when it gets to the end, it jogs the paper up, goes into the next, the slots going the other direction, and Bob's your uncle. Okay. That looks okay. Our cable's still okay. I will, before we button this up, get just a dab of grease and put on that shaft there. While we've got the cassette out here like this, we'll pop that up, clean the head, put a little erase magnet. And for the pinch roller, I don't like using alcohol on those. Some types of soft roller that like paper feed rollers and things are made out of, or typewriter platens, will actually be hardened if you use alcohol. So just a little mild soap. This is, I think, Formula 409. Clean up that pinch roller. It was actually really clean. I don't think this microcassette had a lot of use. Okay. Now, before trying the microcassette, I'm not going to plug the power supply in without having a battery present. As I mentioned before, many of these old systems rely on the battery being present to help regulate the voltage coming from the power supply. So, I remember this ground lead was here, and I mentioned it, and of course I forgot to put it back on there. There we go. Okay. So now we've got our leads and our battery, and I made labels for the battery, and promptly stuck them on the wrong side compared to the original. But that's okay. The electrons won't know any difference. So what I need to do now is solder that battery on there. Okay, I've got my pack and the leads tinned up. What's happening is I'm moving the wire after the solder starts setting, and that can lead to a bad solder joint. That one looks okay. And you don't have to put heat shrink on here, but I like to do so. See if I can do this, not burn myself. Perhaps I'll wind up desoldering it from the board. Now, generally, I replace the battery wires to fully on this. But in this case, these were fine. The pack corrosion was minimal. So I elected not to. Now, what I don't like about doing it this way is there's multiple wires, and the positive and negative are really close to each other on the board. that one went off easy. And oops, I cut this solder tab a little wider. There we go. And a little blue 350 watt heat gun, low speed. Pin those in like that, like they were originally. Now I bent out these wings right here so I could get the original pack out. Kind of a compromise. I didn't want to have to take the whole board out and mess with all the wiring to everything, because that just opens up the possibility for more things to go wrong. And it's also a little disconcerting when I choose to use red wires for ground wires. There. Gonna twist them together, so hopefully I can solder these two in one go. Hopefully my big Charlie Brown head is not blocking the shot. There we go. Okay, positive there, negative there, nothing blew up. Bend those over. Those are kind of a soft steel anyhow. That worked real good for that. And now I need to grease the printer a little bit, and we'll pop the cover back on and see if things move. One point I would like to interject about the battery pack. The cells used back in the 80s when these were made were about 600 milliamp hours. The cells I used are about 3 times that, about 1800 milliamp hours. If you look at the charging directions in the CE 125 manual, it suggests a 15-hour charge time after the low battery LED comes on. So since we have 3 times the capacity, we're going to need about 3 times that charge time if we let it get down to that low battery light condition. Without messing with the charge control resistor, there's not much you can do about that. The good thing is you'll have a lot more runtime once the pack is charged up. These old devices just use a current limiting resistor and time to control the charging. There's no intelligence other than the operator involved. Okay, actually I think before closing this up we should be able to see this run at least. Reset the counter there, and yeah, that looks like fast forward. Rewind, and of course without a tape in there the counter's not moving on rewind, and play. And then eject. Okay, that all looks really good. So now I'll go ahead and close this up, get all the wires tucked in here. Sometimes that's tricky, and then we'll see how it works. This unit came with a tape, but I don't want to experiment with it in case there's anything interesting on it. So I've got another microcassette. These are just standard microcassettes like might have been used in, dictation machines and things like that. And I have a Radio Shack or realistic high power video audio tape eraser. And the idea here is that you want to hold your tape down and squeeze the trigger here and run this over it for a few seconds and erase the tape. basically this is just a big AC electromagnet. So it will magnetize the tape in random directions and thereby erase it. So this was donated by a fellow named Joe. Appreciate it, Joe. It is coming in very handy. Okay, I've got it popped back together with just a couple screws until we make sure everything works. And I'm going to set the computer down on it like this. And you kind of get it in about this orientation where you can see this edge is about lined up there. And it'll slip right over and plug in. And if we turn the computer on, we'll try the printer first, turn the printer on. Press clear. It was very insistent on that in the manual that you press the clear button. Now we should be able to feed some paper. Yeah. I got the paper stuck under there when popping the lid back on. Okay, so printer off, computer off, and we will fix that really fast. Hence the reason for only putting a few screws in the back. There we go. Take the computer out. And get your spudger. Just pop it in there like that. It's got some little indents here along the front and the back that kind of pop it together. There we go. Okay. And of course I knocked the printer out of place. See if I can get this so you can see it. Yeah. There's a couple pegs, one just here that the printer sits on, if you can see that. That's right there. There's one in this corner. Okay. I think if we fold him up like that, you don't want to pull the paper backwards in these little thermal printers. It's usually a good way to break stuff. So ideally you would not have paper in it when you're trying to take it apart or put it back together. But without being able to power this thing up, I just figured I'd leave the paper in there. Okay. I chose to use these two screws because they are machine screws. They thread in the metal, so you're not going to wear the plastic out as you might with a screw that threads into plastic directly. Okay, and I keep unrolling the paper like a party favor. Alright, like that. On, printer on, clear, paper feed. Oh yeah, there we go. Okay, now this paper might be kind of worn out. I can see it's a little discolored right here, just from being in there all those years. Okay, and it says here on the keyboard PNP, and no, that's not the math problem. PNP, that's print or no print. And you notice that is in amber. So if we press Shift Enter, we get the P on there, which means it'll print our answers up here. So if we type in 3.14 times 5. It printed our problem, and if you can see that there, it printed the problem and the answer. And actually, that came out really nice. I'm very happy with that. Okay. So in this configuration using the P, it's just working like an adding machine. So now if we go Shift in P, clear that, go to programming mode. And there are no programs in here, so let's go enter everybody's favorite test program, 10, print Hey space BIRT. These are nice little computers. The screen's a decent enough size. The buttons are rather annoying though. 20 space go to space 10. Okay. Now we should be able to go back to run mode and type in run. And of course, it's just going to keep printing Hey Birt up there. That's pretty exciting, isn't it? And I'll go back to program mode, and if I type in list, it should list out here on the screen. There's line 10. Oops. List. Line 10. Line 20. And I'll list. Should list it out on the printer for us. And that it did, if you can just see that there. Our super comprehensive test program has been printed out. And for decades old thermal paper, it looks halfway decent. It's readable. These weren't the highest quality printers in the world. They were designed to be small and inexpensive and get the job done, and that it did. You can go like that and rip the paper off there, and of course it came with a little plastic cover here, and how does he plug in there? Like that. Okay. Just like that. Now that looks nice. Okay, so our printer works. Keep getting fuzz down in the recesses there. Now we have our freshly erased tape. So if we put that in there and hit rewind. Okay. And one thing on these tapes, like this one was from a work slate slab top computer, it's leaderless. It doesn't have the clear plastic leader on there. Other, computer cassettes that were sold for computer use back in the day would be similar. That way you don't have to worry about running past the leader before you save programs, although a lot of times it's still a good idea because that part of the tape that's exposed when it's all the way rewound is likely to get damaged. So I am going to just fast forward this just a bit, maybe like 5. Okay. Now if I turn remote on, press record, it should leave the motor operation up to the computer now. And if I do C, save, We'll just call this program Hey. It puts a header out before the program and gives it a file name, so you can search through the tape, albeit slowly, to load a certain file by name. And then if we hit enter, and you can hear it, and the tape is rotating. You might just be able to see it there. And of course that was a super short program, so we're done. And that took from 5 to about 13 on the counter. Now in the manual for the CE125 and the PC1251, it talks about a program cassette that came with at least some of them, and it gives the tape counter index to certain programs that are on there, which I thought was a nice touch. Now I'm going to hit stop and rewind. Oops, I got to turn remote off. Okay, I rewound it back to 4. That's kind of a handy use for the remote, is to stop it. And then I will hit play. Okay, it's still not, our tape isn't moving because we have the remote turned on. And we are in program mode, so I will type in new to erase our program. A list to see it's not there. Then we'll do a C load. And tell it to look for Hey. And enter. The cassette is moving, our counter's moving. You can hear the noise from the tape. The screen is blank except for where it says busy. And that looks like it was successful. Let's type in list. Here we go, there's our program. How about that? So we have a revitalized CE125. Now, I'm not sure what's on the tape that came with it, but now that I'm sure it's not going to eat the tape, we can go ahead and try that out. So we'll press clear there, and I'm going to new out the computer and stop it. I'm going to rewind our test tape. This is an official Sharp tape. It says PC1250, 1251. The title is in Japanese, so this may have been the tape I was talking about before that came with the unit. I started trying to learn Japanese at one time, and I should really get back at that. Oh, somebody's written over this. They've put tape over the punch outs to prevent erasing it. Interesting. Okay, so this is side A. Let's rewind that. Oh, it is rewound. Let's fast forward that. If the tape hasn't been used, in years, it's not a bad idea to fast forward it a ways and rewind it just to kind of loosen it up. And it's about 130 on the counter now. I'll just go to maybe 200, 250 and rewind it. And then we'll just see if we can load the first thing on the tape. Okay. And to load just the first thing it comes to, you just type in C load, remote on, play, enter. The tape is playing. Oh, there is something there. And we got something loaded in. So let's list it. And enter, input, Shiten, input Vishukaken. I kind of suspect This may have been one of the programs that came with it. But I'll pop it up here on the screen if it was. But good news, there's something on this tape. There may be some interesting stuff that somebody wrote, so I can play with that later. But the good news is we've got our whole unit here operational. Stop, remote off. We'll rewind the tape again. And I'm going to go ahead and put this guy back in the box. So hold that up there so anybody that's a Japanese speaker can tell us what that means maybe. So there's just the title on the one side there. Maybe I can use Google Image Translate on that. I always find these cases difficult to figure. Okay, a few more tidbits. If we look over on this side, we see a jack that's marked in, and this says adapter. This is for the power adapter, which is this guy. This is out 8.5 volts DC at 350 milliamps. So this is enough to charge the battery. I did a video where I talked about picking out modern adapters for older equipment like this. These are unregulated. It's basically a transformer, a rectifier, and capacitor in a box. So if you're picking out a new modern regulated adapter, there's some additional considerations. I'll link to that video below. And what is this guy marked in here? Well, that involves this audio cable I was not sure about to start with. If you have a cassette for PC 1250, 1251 that was saved on like a full-size cassette, you can connect this up here, this to the headphone jack on a full-size tape recorder and load the program that way. When this is plugged in, it bypasses the input of the microcassette. You cannot save to the external cassette. You can only load from it, which is kind of interesting. And there's a pass-through for the sharp port, which is kind of interesting. I wonder what people might plug in there. You've already got the cassette and the printer, so what else would people plug in there? And I guess we should go ahead and plug this in. I always found it odd that Sharp put the had different ends on these plugs rather than the same end, so makes it a little confusing as to what goes what. And other than that, that's about all there is to this thing. On the back side, there's a place where you can store the cover off the computer. This computer did not have the cover, and I always like putting a sticker on here when I've worked on something to remind me what I did and when I did it. So now I will know. And this thing is now ready to go. Now, as I mentioned at the start, this is a unit I just imported from Japan. This is the US version of it. As you can see, the case is just this much longer. They're the same depth. It just gives you a little more room in here for some extra paper and a few more cassettes. You know, it's got the extra audio cable in here too. Somebody added a Q-tip in a Ziploc bag. And our adapter is the same 8.5 volts out, but this one's 120 volts in, whereas that one was 100 volts in since it was for Japan. And the units themselves are exactly the same from what I can tell. This one did have the little rubber sock on it that came with it originally, whereas this one didn't have that left. And this one I still need to put a battery pack in. It's got no sticker on it. It has the book hidey hole back here. This has this nifty quick reference guide, which is nice. Hadn't seen one of those before. The manual for the electrical engineering library, intermediate mathematics library, CE 125 English instruction manual, and application manual. I will get these scanned. The manual out there for the CE 125 now is not a very good scan, but at least it's something. And I'll scan this one too. This one I'll have to cut apart, unfortunately, to get a good scan, but I think it's worth it, so there's a good one out there. If you have any questions or comments, let me know in that comment section down there below. I would love to hear from you. Thanks to everyone who helps support the Hey Birt channel through Patreon and other means. It is greatly appreciated. And until next time, bye.